Okay, so this is applying trig ratios. So first, going through the steps, so finding sides using ratios. So we have to determine what information we are already given. So for example, we'll look at the triangle and say, are we given legs? Are we given a hypotenuse? Are we given an angle? That would be our first step. Then from there, we're going to choose an appropriate trig ratio. So remember, we would use the SOHCAHTOA, SOHCAHTOA. And remember, that is going to help us remember the ratios for each sine, cosine, and tangent. Then we would set up our equation and solve for our variable. So looking at example 1, notice that we are only given the hypotenuse and an angle. So this is our given information, the hypotenuse and our angle. We are missing both legs. So I'm going to go ahead and label that X and Y. Okay. And what we're going to try to find first is Y. So notice that Y is directly across from that angle 32. So that means we have something that is opposite of our angle, and we also have the hypotenuse. So which of our functions gives us opposite and hypotenuse? The sine. Good. So we would write this as the sine of theta is equal to opposite over hypotenuse. Well, theta is our angle, and we know our angle is 32, so sine of 32 is equal to opposite, which is y, we don't know y, divided by hypotenuse, which is 37. Well, what do we have to do to both sides to get y by itself? Multiply by 37. So we have y is equal to 37 sine 32. And from here, we're just going to type it into our calculator. Before you type anything to your calculator, I want you to double check your calculators and make sure that they are in degrees, not radians. So your calculator needs to be in degrees, not radians. And how you change that is I want you to go ahead and hover with the mouse pad up where it says radians, and you can click on it and it will change it to degrees. Or if you need it in radians, you click on it again and it'll change back to radians. Okay, so on the calculator, and I'll show you here. Look at the top of my calculator. Do you see how mine says the DEG? That is degrees. Your calculator needs to say the same or you're going to get a different answer. Now, to solve this, we're going to type in 37 sine 32. So 37, So 37, and then right next to that 7 is the trig button. You're going to click on the trig, and we're going to use sine. So click on sine, and then we're going to type in our angle, which is 32. And then you just hit enter. And if it doesn't give you in decimals, go ahead and hit Control, Enter, and you should get the answer 19.607 degrees. Or sorry, not degrees, the side angle. So this is 19.607. If you get a length that is different than 19, so if you get like 20 point something, that means your calculator is in radians. So make sure that it's in degrees. Okay. So we now found y, and y is 19.607. It is the length of side y. Okay. Now we need to find x. So if we're looking again at our angle 32, notice that x is right next to that angle. And what's another word for right next to?
Adjacent.
Adjacent. So we have x that is adjacent to the angle, and then we have the hypotenuse. So which trig is adjacent in hypotenuse? Cosine. Okay, so I'm going to write cosine of theta is equal to adjacent over hypotenuse. Okay, so that's cosine of 32 is equal to x divided by 37. I want x by itself, so I'm going to multiply both sides by 37. So I get x is equal to 37 cosine 32. And you're going to plug that into your calculator. And you should get 31.378. So I want everyone to type that into your calculator and make sure you're getting the same number that I'm getting. 31.378. Okay. So while you guys are doing that, another way that you could go about this is, okay, well, we have a leg, we found y, and we have our hypotenuse, so we could have just used the Pythagorean theorem to find the missing leg. So once you do the trig ratio for 1, if you want to use Pythagorean theorem to solve the other side, that is okay. Both will be fine. Personally, I think this is easier as long as you just know your ratios for sine, cosine, and tangent. Okay. Everyone get the same number? Okay. Let's look at number 2. Okay, on number 2, what information are we given? Oops, sorry. The angle and the hypotenuse. So here's the hypotenuse, here's an angle. So that means we're missing both legs, so I'm going to go ahead and label them again, x and y. It doesn't matter what you label them, as long as you write it on the diagram, then I know what number is going to belong where. Okay. Just make sure whatever variables you're using for the lengths is a lowercase variable, because our uppercase variables are representing our angles. Okay, so let's go ahead and start with, let's try to solve for x. Okay, so if we're trying to solve for x using that 25 degrees, x is in what relation to that angle? So if we're looking at our angle and we're looking at x, is x opposite or adjacent? Adjacent. Adjacent. And then we have the hypotenuse, so which one is adjacent and hypotenuse?
X is adjacent and 4 is
which trig function? Cosine. Sine or cosine? Yeah, cosine. So I'm going to write cosine of theta is equal to adjacent over hypotenuse. Cosine of 25, because theta is our angle, is equal to adjacent, which is x, divided by hypotenuse, which is 4. And we would have to multiply both sides by 4 to get our x. So x is equal to 4 cosine 25. Type that into your calculator. You should get 3.625. Okay, you should be verifying that when you type that in, you get the same number as me. Okay, and it's not something different. And if it is, let me know so I make sure that for 1, your calculator is in degrees, and 2, that you're typing it in correctly. The next side we're going to try to find is y, and notice that y in regards to our angle 25 is what? Opposite or adjacent? So we're looking at y and we're looking at our angle 25. Is it opposite or adjacent? Opposite. Opposite, and since it's opposite and we have the hypotenuse, we use sine. So sine of theta is equal to opposite over hypotenuse. So sine of 25 is equal to y over 4. Same thing, in order to get y by itself, we're going to multiply both sides by 4. So y is equal to 4 sine 25, which in your calculator is 1.690. Okay, so again, once you have this written down, double check that you're getting the same number on your calculator. Okay, any questions on 1 or 2? Okay, 3 says find the missing side lengths. So here, we're no longer given a hypotenuse. We are now given a leg and an angle, which means we are missing our hypotenuse that I'm going to label H, and then we're missing a leg that I'll just go ahead and label X. Or, sorry, I should not write a capital H. I should write a lowercase h. Okay. So, looking at our angle of 43 degrees, if I want to find X first, X is adjacent or opposite of the 43? Adjacent. And then I'm only given the leg of 15, and 15 is what? Opposite or adjacent? Opposite. So I have an adjacent and an opposite, which means I'm using sine, cosine, or tangent? Tangent. So tangent of theta is equal to opposite over adjacent. So tangent of 43 is equal to opposite, which is 15, divided by adjacent, which is x. So we don't know x yet. Well, we need to get x by itself. So one way we could do this is we could take tangent of 43, make it into a fraction by writing it over 1 and flipping both sides. That way we get the x out of the denominator. So this would be 1 over tangent 43 is equal to x over 15. And then our last step would be to multiply both sides by 15. So we have x is equal to 15 tangent of 43. Sorry, 15 divided by tangent of 43. You would type that into your calculator. So everyone take a minute, type that in your calculator. Make sure you're either putting tangent 43 in parentheses or using the fraction part on your calculator, which is control divide. Okay, and you guys should have got 16.086. Remember, in order to find these trig functions, you're going to hit the trig button, which is right next to number 7 on your calculator. Okay. So we found our other leg. Okay, so now we have 2 legs and we're missing the hypotenuse. So you could do one of 2 ways. You could use the Pythagorean theorem, a squared plus b squared equals c squared, to find your hypotenuse. Or you can use the trig ratios. Okay, either way you're going to get the same answer. I'm just going to continue using the trig ratios. Okay, so I'm going to write up here that this is 16.086. And now I'm going back and I'm looking at that triangle, and now I'm going to try to find the hypotenuse. So if I'm using the same angle of 43, my hypotenuse is there, and then across from it, opposite of it, would be my 15. So which function is opposite and hypotenuse?
Tangent? Oh, wait. Oh, sin.
Sine, good. So we do sine of theta is equal to opposite over hypotenuse. So that's sine of 43 is equal to opposite, which is 15, divided by hypotenuse. Again, since my my variable is in the denominator, I want it out of the denominator. So I'm going to put sine 43 over 1 and flip both fractions. So that's 1 over sine of 43 is equal to h over 15. And then in order to get h by itself, I'm going to multiply both sides by 15. So h is equal to 15 divided by sine of 43. You would put that in your calculator and get 21.994. Any questions on number 3? And if later after the notes you want to try it the other way using the Pythagorean theorem just to compare, you can, and you'll notice that you'll get the exact same thing of 21.994. Okay, so that's the first part of the notes, is how to find those missing sides using the trig ratios. The other part of the notes is how to find missing angles. Okay. So the steps for finding a missing angle is to first, just like before, determine what information we already have. Okay. Then we have to choose the appropriate trig function, and we solve using the inverse trig function. Okay. So if we need to solve for an angle, in order to get that angle by itself, we're just going to take the inverse. So if we use the ratio sine, then in order to get the angle, it would be inverse sine. Okay. Same with tangent. If we use the tangent, we need to find the angle, we just use inverse tangent. Okay. So looking at example 4, I'm going to write the SOHCAHTOA again at the top. Remember, that is sine, cosine, and tangent. Okay. And then here, I'm going to go ahead and label everything that is missing. So I know that this angle right here at the little square is a right angle, so it's 90 degrees. But I don't know the other two angles, so I'm just going to label them angle A and angle B. Okay, and make sure they're capital letters because capital letters are depicting angles. Okay. From here, I want to try to solve for angle A. So if I'm trying to solve for angle A, notice that I'm given the hypotenuse, and then that number 4, which is what? Opposite or adjacent? Adjacent. So would I use sine or cosine? Cosine, because cosine has the adjacent. So I would write cosine of angle A is equal to adjacent over hypotenuse, so 4/7. Well, once I have this equation set up, I'm not able to type this into my calculator just yet. I have to get A by itself, which is the angle. And I do that by taking the inverse of the cosine. So A is equal to cosine inverse of 4/7. Notice that that fraction didn't flip or anything. The only thing that changes is the trig function. Okay. So just like you did before, you're going to go on your calculator, and I'll do this one with, let me grab my calculator. Okay. So we're going to go to the trig function here. I'm going to find cosine inverse, so it's the cosine with the -1 at the top. And then I'm going to type in 4 divided by 7. And then hit enter. And then if I need to approximate it to get an angle measure, it's going to be 55.1501. Okay, everyone get the same thing on their calculator? Okay. Okay, so A is equal to 55.15 degrees because we're talking about angles now. That means we now have angle A. We have the 90-degree angle, but we're still missing angle B. Okay. What do we know about triangles if we add all the angles together? They equal 180. So I could write that angle B is equal to 180 minus 55.15, which is angle A, minus 90. And if I just plug that into my calculator, I will get angle B without having to use any of the inverse trig functions. So this is equal to 34.85 degrees. Of course, you could use the inverse functions to find that other angle, but we already know that all the angles add up to 180, so we're just going to use that knowledge instead of going back to the ratios. But either way you do it, you will be correct. So on the quiz that we have on Monday, okay, either way that you do this will both be correct. Okay, you can choose either way. Any questions on number 4? Number 5. So notice on number 5, we're given a leg and we're given the hypotenuse. We also know that this angle right here is 90 degrees, but we don't know the other two angles. So we need to find angle A and find angle B. Okay. So in order to find angle A, notice that we have this leg right here, which is opposite or adjacent? Adjacent. And then the hypotenuse over here. So which trig function is adjacent and hypotenuse? Cosine. So I would do cosine of A is equal to 17.5 divided by 19. I need to get the angle A by itself, and I do that how?
You did the inverse of cosine.
The inverse of cosine. So A is equal to cosine inverse. My fraction of 17.5 over 19 stays the same. And you're going to plug this exactly how it is in your calculator, and you'd get 22.919 degrees. Okay, and you can round this to 2 or 3 decimal places. Either is fine. Which means I now have 2 of my angles. So what am I going to do to find angle B? Subtract the other 2 from 180. So B is equal to 180 minus 22.919 minus 90. I put that in my calculator and I get 67.081 degrees. Don't forget to add that this little circle that I'm adding above the numbers. That is to identify this as an angle in degrees. Any questions on, oh, I just noticed there's 2 number 5s. On the first number 5. Okay. Looking at the next one, notice that we no longer have a hypotenuse. Instead, we have 2 of the legs. So right away, since you see we do not have a hypotenuse, can we use sine and cosine as our ratios? No, so that means we have to use what as our ratio? Tangent, okay? So first I'm going to label everything. So this is 90 degrees, this is angle A, this is angle B. I'm trying to find angle A, and I just said, okay, well, I don't have this hypotenuse right here of H. So I know I can't do sine and I can't do cosine, so I have to use tangent. Well, tangent of angle A is equal to opposite over adjacent, so 6 divided by 20. And in order to find that angle A, I need to do the inverse. So A is equal to the inverse of tangent of 6 divided by 20. I put that exactly into the calculator and I get 16.699 degrees. Which means I now have 2 angles and I need to find that third angle, so I can just subtract those other 2 angles from how many degrees? 180. B is equal to 180 minus 16.699 minus 90, and I get 73.301 degrees. So now on to the last one. And before we solve this, I want to show you guys some symbols that you're going to see on your practice. Okay, so if you haven't taken geometry yet, they might not look familiar. And one of those symbols is this. It looks like M, and then it looks like it's a less than symbol, but the edges kind of curve out a little bit. This right here is the same as saying the measure of the angle. So instead of writing out measure of the angle every single time, they created this symbol of M and then that less than looking kind of symbol, measure of the angle. Okay. Another thing is that when we have our angles measured, or sorry, labeled. So let's say this is A, B, and C. Okay. Wherever that angle is, the opposite of that angle is how we label the side. So for example, the opposite of this angle C would be labeled a little c. Okay. Which means the opposite of this angle B would be labeled what? The little b, the lowercase b. And the opposite of this angle A would be labeled lowercase a. Okay, you're going to need that for the last two questions on your practice. So just a heads up, that is how you are labeling all the sides, and that's what that symbol stands for, the measure of the angle. Okay. Now continuing and solving this problem, we labeled everything. Let's try and do something a little different and find B first instead of finding A. Okay, so looking at angle B, we know that we have the hypotenuse, which is 14, and we also have 11, which is opposite or adjacent. Looking at B, is 11 opposite or adjacent of B?
Adjacent.
Adjacent, so that means we're using cosine. So cosine of B is equal to adjacent divided by hypotenuse, so 11 over 14. In order to get the angle B by itself, we take the inverse. So B is equal to the inverse of cosine of 11/14. You put that in your calculator and you get B is equal to 38.213 degrees. Which means we now have two angles here. We have B that we just found, and angle C we know is 90 degrees. So in order to find A, I can just subtract those two values from 180 to get my answer. So 180 minus 38.213 minus 90 is equal to 51.787 degrees.